Welcome back to my channel. So in this class we will discuss these two topics in this lesson: acids, bases and salts. First one is chloroalkali process and second one is derivatives of sodium chloride. Chloroalkali process. In this process we will discuss the preparation of chlorine gas, hydrogen gas and caustic soda. Caustic soda means sodium hydroxide, NaOH. So here for that I have taken electrolytic cell. In this cell I took brine solution as electrolyte. Brine solution is made up of mixture of sodium chloride and water. So we should take more amount of sodium chloride salt into the specific amount of water. So only specific amount of sodium chloride will be dissolved in the water. The rest of the sodium chloride will be settled at the bottom of the beaker. So that is called a saturated solution. So that kind of saturated aqueous sodium chloride solution is taken as electrolyte in this process. Brine solution means saturated aqueous sodium chloride solution. Here in this chloroalkali process, what is the electrolyte? This type of question will be come to the exam. So what is the brine solution? That is saturated aqueous sodium chloride solution. So it is formed by mixture of sodium chloride and water. Sodium chloride and water. Okay, next in this brine solution I have dipped two electrodes. Electrode here, the charge of electrode depends on the terminal of the battery. So here anode is connected to positive terminal of the battery, cathode is connected to negative terminal of the battery. So anode has positive charge, cathode has negative charge. Here anode is made up of graphite and cathode is made up of mercury. And one more thing, at anode what type of reaction takes place? Oxidation reaction. Oxidation reaction means removal of electrons. Removal of electrons in this process. And reduction means addition of electrons or gaining of electrons. Okay, so here at anode what type of gas will be liberated? Chlorine gas is liberated. At cathode hydrogen gas is liberated. So not only hydrogen gas is liberated but also sodium hydroxide is nothing but caustic soda is formed under the cathode. So that's why this process is called a chloroalkali process. Chloro means liberation of chlorine gas at anode. Alkali means sodium hydroxide. It is the alkali solution. Alkali solution means the base which is dissolved in the water is called alkali solution. So here sodium hydroxide is the one of the alkali solution. So that sodium hydroxide is formed at a cathode. So that's why this process is called chloroalkali process. So chlorine gas is liberated at anode and alkali solution is formed at a cathode. So not only caustic soda, H2 gas also liberated at a cathode. Okay, so now whenever we switch on the battery, that current will be passed into the electrolytic solution. That electrolytic solution is nothing but a brine solution. Then what will happen? Since brine solution is made up of sodium chloride and water. So then the sodium chloride, aqueous sodium chloride is ionized into Na plus Cl minus. So we better to take 2 moles of sodium chloride, then 2 moles of Na plus and 2 moles of Cl minus ion are formed. These are the aqueous. Okay, so now we know that at anode oxidation reaction takes place, at cathode reduction reaction takes place. What is the charge of anode? Anode has a positive charge. So here at positively charged anode, what type of ions will be migrated? That is negatively charged ions, means anions. So what are the anions in this? Chloride ions. So that is 2 moles of chloride ions. 2 moles of chloride ions will give 2 electrons and converted into chlorine gas. This is what type of reaction? It is a oxidation reaction. Oxidation reaction. So like that, here at a cathode what type of reaction takes place? That is reduction reaction, because cathode has a negative charge. At negatively charged electrode, what type of ions will be migrated? That is a positively charged ions, means cations. Cations migrate towards a cathode, anions migrate towards a anode. So here, what is the cation here? Sodium ion is cation. So that is 2Na plus ion gains 2 electrons. And here, dissolved in the water, just take a 2 moles of water, forms a NaOH, 2 NaOH plus H2 gas. Plus H2 gas. Is this balanced? 2 sodiums, 2 sodiums, 2 oxygens, 2 oxygens, 2 to the 4 hydrogens, here 2 hydrogens, here 2 hydrogens. Understand? So here at a cathode, reduction reaction takes place. So that is 2 Na plus ions are gaining 2 electrons, which are given by chloride ions at anode and dissolved in the water. So forms a 2 moles of sodium hydroxide. This is a caustic soda. This is a caustic soda. This is hydrogen gas liberated at a cathode. So here 2 kinds of substances are formed at cathode, that is sodium hydroxide and a hydrogen gas. This is a chloroalkali process. In the exam they will ask what type of gases will be liberated at anode, liberated at a cathode, and at which electrode alkali solution is formed. So what is the electrolyte in the chloroalkali process? And what type of chemical reaction will be occurred at anode? What type of chemical reaction will be occurred at cathode? So these type of questions will be come to the examination. Okay, now come to the second one, derivatives of sodium chloride. So here, based on the sodium chloride, we can prepare number of compounds. So some of the compounds I have written on the board. So first one is sodium hydroxide, already we have prepared here. So in this, what is the raw material, means starting substance? That is sodium chloride only. Okay, so here from sodium chloride we can prepare sodium hydroxide also. So in this, at anode chlorine gas is liberated. At cathode H2 gas and sodium hydroxides are formed. Next, the second one is bleaching powder. Bleaching powder formula is CaOCl2. Calcium oxidichloride. It is the bleaching powder. So here, whenever we pass chlorine gas, okay, so here chlorine gas is obtained in the chloroalkali process by the using of sodium chloride only. So it is also derivative of a sodium chloride only. So here, whenever we pass chlorine gas through lime water, CaOH taken twice, it is aqueous lime water. So whenever we pass chlorine gas, then what will happen? CaOCl2 plus H2O. Calcium oxidichloride and water are formed. This is called CaOCl2 is called a bleaching powder. Bleaching powder. Next to baking soda. Baking soda formula is NaHCO3. Baking soda formula is NaHCO3. NaHCO3 means sodium hydrogen carbonate. Sodium hydrogen carbonate or sodium bicarbonate. Okay, so here how does it prepare? How does it prepare? Simple. So here we have to take a sodium chloride and we should take some amount of water, means it is called brine solution, and we should add ammonia and we should pass CO2 gas. Okay, so in this first one we should take brine solution. The mixture of sodium chloride and water is called a brine solution. Brine solution. So for whenever we pass the ammonia gas and carbon dioxide gas through the brine solution. So here we will get sodium hydrogen carbonate plus ammonium chloride. Ammonium chloride. Is this balanced? One sodium, one sodium. One nitrogen, one nitrogen. One C, one C. Hydrogens how many here? 2, here 3. 5 hydrogens, here 4, here plus 1. 5 hydrogens. How many chlorines here? 1 chlorine, 1 chlorine. So here all elements are balanced on both sides. Okay, whenever we pass ammonia gas and carbon dioxide gas through brine solution, here we have gotten sodium bicarbonate is nothing but baking soda and ammonium chloride. Ammonium chloride. Next, washing soda. Washing soda formula is Na2CO3 dot 10H2O. Decahydrated, 10 means decahydrated sodium carbonate is called a washing soda. So this washing soda is formed by the thermal decomposition of sodium hydrogen carbonate. Thermal decomposition of sodium bicarbonate. Take here 2 moles. Thermal decomposition. So here Na2CO3 plus CO2 gas plus H2O. Okay, how many sodiums? 2 sodiums, 2 sodiums. 1 here 1, 2 carbons, 2 ones are 2 carbons. 2 3 are 6 oxygens, here 3, here 2, 5 plus 1, 6. How many hydrogens here? 2 ones are 2 hydrogens, here 2 hydrogens, balanced. So whenever we heat the sodium bicarbonate is nothing but baking soda. Here we have gotten sodium carbonate and carbon dioxide and water. So this is anhydrated sodium carbonate. There is no water molecules. So it is not called as a washing soda. So here whenever we add a fixed number of water molecules, so that is Na2CO3 is mixed with 10 moles of water molecules, it is converted into Na2CO3 dot 10H2O. So it is called a washing soda. It is called a washing soda. So it is a anhydrated sodium carbonate. Anhydrated means without water molecules. Without water molecules. Understand? And fifth one is plaster of Paris. Fifth one is plaster of Paris. Plaster of Paris. So it is also called POP. POP. So here its a molecular formula is CaSO4 dot of H2O. Its chemical name is hemihydrated calcium sulfate or semi-hydrated calcium sulfate. Of means hemi, H-E-M-I, hemi or S-E-M-I, semi. Hemihydrated calcium sulfate or semi-hydrated calcium sulfate is called plaster of Paris. It is obtained from the gypsum. It is obtained from the gypsum. So that is a CaSO4 dot 2 moles of H2O. So whenever we heat this salt at a 363 Kelvin temperature, then we will get CaSO4 dot of H2O plus 3/2 moles of H2O. So this is called POP, plaster of Paris. So in the examination they will ask mainly what are the uses of derivatives of sodium chloride. For 4 marks question we can guess this question. For 4 marks question. So in every exam you can check the previous papers. In that one of the question will be come from this lesson only, that is uses. So that is uses means here derivatives of sodium chloride only. So in this mainly important are this one, bleaching powder, baking soda, washing soda and POP. They will ask what are the uses of these 4 derivatives of sodium chloride. In objective purpose maybe they will ask molecular formulae. Understand? So these are the two topics we discussed in this class. If you get any doubt in this concept, you can mention in the comment section. I hope you understood. Thank you.